The P219A diagnostic trouble code indicates an air-fuel mixture imbalance in bank 1 of your engine. This code is triggered when the powertrain control module detects that the air-fuel ratio is not within the optimal range. Bank 1 refers to the side of the engine that contains cylinder number 1. In most engines, this is clearly marked and helps technicians identify which side of the engine is experiencing the imbalance. Several factors can trigger this code. Modern diagnostic research shows that fuel system issues are the most frequent cause, accounting for 45% of all P219A occurrences. Fuel system problems include clogged fuel injectors, fuel pump pressure irregularities, contaminated fuel, and malfunctioning fuel rail pressure sensors. These issues prevent the engine from receiving the correct amount of fuel. Air intake problems account for about 30% of P219A occurrences. These stem from vacuum leaks, contaminated mass airflow sensors, carbon buildup in the throttle body, or restricted air filters. Sensor malfunctions contribute to approximately 20% of cases. This includes faulty oxygen sensors and issues with the manifold absolute pressure sensor, which help the engine management system monitor air-fuel ratios. Finally, mechanical issues make up the remaining 5% of cases. These include compression loss in cylinders, exhaust leaks before the catalytic converter, and PCV system malfunctions. Modern vehicles with advanced OBD2 integration and more sensitive sensors can detect even small deviations of just 2 to 3% from optimal air-fuel ratios. This increased sensitivity makes accurate diagnosis crucial for proper repair. Diagnosing the P219A code requires a systematic 5-step approach that modern technicians use to identify and resolve air-fuel ratio imbalances efficiently. Step 1 involves analyzing live sensor data during various engine loads. Modern diagnostic tools monitor real-time parameters to identify patterns that indicate air-fuel ratio problems. Step 2 focuses on fuel trim evaluation. The system continuously adjusts fuel delivery based on exhaust oxygen content. Positive fuel trim values indicate the system is adding fuel for lean conditions, while negative values show fuel reduction for rich conditions. Step 3 involves systematic component testing of both fuel delivery and air intake systems. This includes testing fuel injectors, fuel pressure, and air intake components to identify the source of the imbalance. Step 4 uses smoke testing for advanced leak detection. This technique helps identify vacuum leaks in the intake system that can cause air-fuel ratio imbalances by introducing unmetered air into the engine. Step 5 requires extended drive cycle testing to confirm repair effectiveness. This validation ensures the P219A code does not return and the air-fuel ratio remains balanced under various operating conditions. Repair strategies depend on the root cause identified during diagnosis. The 3 main categories are fuel system repairs, air intake system repairs, and sensor replacements. For fuel system issues, cleaning or replacing fuel injectors is often necessary. Clogged injectors disrupt proper fuel delivery, causing rich or lean conditions that trigger the P219AA code. Air intake problems require fixing vacuum leaks and cleaning components like the mass airflow sensor and throttle body. These components must be clean and properly sealed to ensure accurate air measurement. Sensor replacements are common for faulty oxygen sensors and manifold absolute pressure sensors. These sensors provide critical feedback to the engine control module for proper air-fuel ratio management. In some cases, a PCM reflash with updated calibration software resolves false P219A triggers. Preventive maintenance, including regular fuel system cleaning and using quality fuel, helps prevent future occurrences of this code.